Hey guys, we are back with our Jam Achiever series and this is lecture number 5. And today's topic of discussion is the mass vesting and this is part 1 video. Welcome to my channel Success Guru and myself Panchanadam and let's get into the heading. So actually what is mass vesting? A mass vesting is a temporary instability of superficial mass of soil and rock may leave their original position abruptly or extremely slowly. They start either a downslope movement or vertically downward sinking. These movements of ground are broadly termed as mass wasting or mass movements. So this is what a shortest definition for mass wasting or mass movements. So this is a temporary phenomena which happens a sudden or slow movement of landmass along the slope, or sometimes it may happen like a vertically downward sinking. So all this type of rock movement or soil movement, or we can simply call it as mass movements, comes under this heading that is called mass wasting. Is that clear? So here you can expect a slope downslope movement, and that can be a slow process or sometimes it can be a faster one, and also you can expect a downward sinking of land. Okay, so we'll see what are this, and I will try to cover what are the types of mass movements, how it is classified, what are the causes of mass movements, and what are the controlling factors for this type of mass movements. We will try to cover all these headings, but for this video I will try to cover what are the types of mass movements. Okay, so let us see what are the types. Actually, mass movements are broadly categorized into three broad categories based on the type of failure. If the failure occurs over a definite surface, then it is called as sliding. If the failure is not over at any definite surface, then it is called simply a flowage. And if the mass actually sinks down vertically down, then it is called as subsidence. So you can simply remember like this: if the mass movement is on a slope, there will be two categories. One is flowage and sliding, where sliding implies a definite surface of failure, whereas flowage implies there is no any definite surface of failure, and subsidence there is no any involvement of slope. It is actually sinking of land. Okay, so we'll see the detail of these things, and actually this broad categories have been subclassed into many headings based on the rate of movement, nature of mass involved in the failure, and degree of saturation. So we will see one after the other. The first category here what we are going to discuss is the flowage. So as I mentioned earlier, here there is no any definite plane of movement. So that is what first requirement for the classification under flowage. Okay, here you can expect the movement material will be unconsolidated nature, generally unconsolidated sediments, or even you can expect grains or group of grains. Okay, and here the behavior as if it moves on its own surface of failure, that is movement distributed throughout the matter. So this is what a flowage generalized definition, where you cannot expect any plane of displacement over which the displacement actually occurs. Then the material involved are generally unconsolidated sediments, and here the movement is distributed all along. So this is what a flowage is, and this is further subdivided into slow. Then you can in the slow type there is a called category called creep. So let us see one after the other. When the flowage is very slow, okay, so how to find that there is a movement of grain? Okay, so you need certain evidence to prove that. The first one is the curved trees. So you can see in this image this is a curved tree, which is a direct manifestation that the mass, that is the overall mass, is sliding down. You know why? Actually, the tree or plant will grow vertically up, right? But you can see here the trunks are turned, right? So this indicates this position, current position of the tree is actually not at the earlier one. So actually the mass is moving down the slope. But what happens, that plants and tree try to grow vertically up, and that leads to the appearance just like this, that is the curved trees. Not only this, you can expect tilted fences, tilted telephone lines and telegraph poles. So these are some of the evidence that the movement is actually happening here, but at a very slow rate. Okay, this type of slow movement are termed as creep, and this creep have been further subdivided into two. One is a shallow creep, other is the deep creep, which means the thickness of the mass that actually involved in this type of movement is very less, then it is called as shallow creep. If the thickness of rock mass that involves in this type of movement is very higher, then you can call it as a deep creep. And actually this creep is also further subdivided according to the material that involved. They are called as soil creep, talus creep, rock creep. All those things comes under this when the movement is very slow. Okay, so this is what creep is. In slow flowage there is also another category. This is called as solifluction. There is always a controversy in placing this type of mass movement in flowage or subsidence. Okay, this is called a pattern ground. Okay, so this comes under solifluction, which is actually the process that is responsible for the formation of this type of pattern ground. So let me explain what is this. So this is a distinct symmetrical natural patterns of geometric shape formed by the deformation of the ground material in a periglacial region, which involves repeated cycling of freezing and thawing. So actually this is done by what we already studied in geomorphology, that is in weathering, that is frost heaving. Okay, so actually what is happening here is that when the ground containing water, when it freezes, what happens? It freezes and expands. As you know, when water is frozen, its volume increased by 9%, right? So this leads to the expansion of the groundwater, which is actually frozen. Okay, and this causes the soil and rock to be pushed upward and outward. And this repeated freezing and thawing creates various geometric shapes such as polygons. So you can see here there is a different type of what do you call pattern here, which is called as a pattern ground. So which is formed due to the melting and freezing of the groundwater that lies below this. When the raw water freezes, what happens? Its volume increases, which actually push the material up and away. When it melts, what happens? There will be a free space, right? So once again this material settles down. So this repeated cycle leads to a separation of materials according to the grain size, which we call it as a sorting, right? So here you can see all this bigger grains forms at the margin, and almost less sized grain like fine sand or medium sand that lies in the center. This is how it is formed, which comes under this flowage, which is also under the slow process. Okay, the next one is the rapid flowage, where you can expect a fast movement of material down the slope. And actually this is a dangerous phenomena which happens and which can lead to loss of material property and even sometimes life. Okay, so this is further subdivided into earth flow, which simply means overall the rock along with soil along with vegetation cover, everything moves down. So this is simply called as earth flow, which happens in a fraction of seconds to certain minutes. Okay, so this is called as earth flow, which comes under the flowage. The second subdivision is the mud flow, where the particular size of the grains moves down. Here it is mentioned as mud. So that moves down the slope. It is called as a mud flow. Then we have our rock glacier, which means the rock along with the glacier moves down the slope. This is called as log glacier. And we have the last category, that is a stone stream. When the land is so dry, when it is not having any grip position, it moves down automatically, right, due to gravity, and that forms the stone stream. So these are the subdivisions of flowage. Okay, is that clear? So now we will try to cover what is sliding. As I mentioned here earlier, here the failure is along a definite surface. Okay, so when I am mentioning about a definite surface, this surface can be a planar surface or a semicircular surface. There are two probabilities, right? So this displacement can be happening over a planar surface or over a semicircular surface. If you are seeing any planar surface of failure, which simply means the rock that involves in the mass wasting or mass movement is brittle in nature and actually cohesive rock. So these two thing decides whether the surface should be planar or semicircular. If the material that involves in mass movement is unconsolidated and loose sediments, then you can expect a semicircular surface along which the rock has been moving down. Okay, so this is a sliding where there is a definite surface of failure is present, and that definite surface can be a planar or semicircular. If it is planar, then it indicates the rock that involves in rock mass movement is brittle and cohesive in nature, and if it is semicircular, then it implies that the material involved downslope movement is definitely unconsolidated and loose sediments. Okay, is that clear? So let us see the subdivisions of this type of sliding. Okay, so the sliding can be broadly categorized into three groups. One is translational, right, which simply indicates this is just sliding. There is no any rotation or toppling is happening. Okay, so translational movement indicates only the rock slides down, and this is further subdivided into first one rock slide, where a particular rock slides along a particular plane, which is a rock slide. Then we can see debris slide, which simply means more than one or two rocks together slides down a particular plane, that is called as a debris slide. Okay, then the second category is rotation. Here actually rock is rotating. In translational movement, there will be no any angular change between the initial and final position of the rock, whereas in rotational sliding there is a change of angle between the initial and final position of the rock. So the rotation, you can see the sliding is in like this. So here this is further subdivided into two. One is single rock slip, which simply means there is only one plane of sliding. So here there are more than one, but if it is there is only one plane of sliding of a rock, it is called as single rock slip. If there is more than one, you can simply call it as multi rock slip, just like this. So here the slipping happens from here to here, and here also there is a slipping, and if you can see there is also a minor displacement here. So this comes under multi rock slip, and as I mentioned earlier, this curved surface is indicating that this is an unconsolidated sediment. Okay, and the final one is just fall of rock, right? So this is called as falling. Simply this category comes as falls, where the rock simply falls from its position to the plane surface. There is no any sliding or any rotational movement. So this is further subdivided into rock fall, where a single rock type is falling from the slope, where the slope is actually steeper, right? The second one is debris fall, where more than one type of rock involved in falling in a steep slope surface. This is called debris fall. Okay. So sliding, we have three categories, and we are explaining what are those, right? So last one, that is subsidence, which is a vertical or downward sinking of land. With this, so you can see the image here where the land mass has sunk down. This can be due to two reasons. One is natural cause, another is artificial cause. Natural cause we can already studied in our geomorphology in limestone groundwater erosion, right? So when there is a limestone terrain, if the groundwater moves, what happens? It will try to dissolve the calcium carbonate, and that will form a sinkhole, which is called as collapse sinkhole, right? So that comes under this type of subsidence, which is a natural cause. If you can expect, there are sinkholes in big cities where there is a over exploitation of groundwater. So that is an artificial cause, where the over exploitation of groundwater leads to the creation of a space between the grains, where the friction is less and the land try to subside. So this is also possible for the occurrence of this type, which comes under subsidence. Okay, so these are the types of mass vesting. As I said, if there is a definite plane of sliding, then it is called as sliding. If there is no any definite plane of movement, then it is called as flowage. If the movement is vertically down or sinking, then it is called as subsidence. Is that clear? So we'll try to cover what are the different controlling factor, all such a thing in the upcoming video. Thanks for watching. Have a great day.